Okay, I'm going to look at this and say, well, there's my y prime. I've got t's and y's, so this is not autonomous, and it is not a pure time differential. I might then think, is it separable? But there's no way to write this as a function of t times a function of y. So our next hope is that it's first order linear, which means we have to be able to rearrange this to look like y prime plus something times y is equal to something. And that'll be my p function and my q function. Well, if I add the y, oh, I said y, I wrote t. Y prime plus something times y is equal to something. So if I add this y over, the something in front of the y will be a 1. And it's going to leave me with a 2t over here on the right-hand side. Now that it's in our standard form for first order linear differential equations, I'm going to go ahead and find our integrating factor. Formula is always the same for that integrating factor. I'm looking for e to the integral of p dt. Well, the integral of 1 is just t, so that's going to be e to the t. Next step, I'm multiplying every term through by our integrating factor. I'll have e to the t y prime plus e to the t y is equal to e to the t times 2t. The right-hand side here should always work out to be a product rule of y and our integrating factor. We're going to undo the product rule on the left-hand side, which really just means we're not going to write the prime again. And on the right-hand side, oh, I lost my... On the right-hand side, we're going to integrate that with respect to t. So I've got 2t e to the t dt. This, if I walk up to it, I'm thinking, is algebra trig or a mixture of stuff? Well, it's a mixture of algebra and an exponential function. I'm going to do a quick check for a U-substitution. If that had been t squared up there, then that U-sub would have popped out. It's not, it's just a t. I'm going to have to integrate by parts. If u is equal to 2t, then dv would be everything else, the e to the t dt. Finding that antiderivative, I'm looking at e to the t and taking the derivative of u, I'm going to get du is equal to 2 dt. So I'm looking at u times v, or 2t e to the t, minus the integral of v du, 2 e to the t dt. We've still got that y e to the t over there. So I'm looking at 2t e to the t minus 2 e to the t plus a constant. One of the common mistakes when doing these first order linear differential equations problems, if I want to get the y by itself right now, I'm going to divide everything by e to the t. Well, it sure looks like that means the e to the t's are going away on the right-hand side. The common mistake is ignoring the plus c. So when I divide through by e to the t to get y by itself, I'm dividing each term by e to the t. So it's true that the e to the t's cancel out in that term and they cancel out in this term, but we can't ignore this part. E to the t is not a constant, so that constant over e to the t has to stay. So this is going to leave me with y is equal to 2t minus 2 plus, and I could rewrite that to say c e to the negative t. And that would be our general solution. Because we were given an initial condition, we do want to go ahead and solve for c. So y is going to be 1 when t is 1. So 2 minus 2 plus c e to the negative 1. Those 2's are going to cancel. And if 1 is equal to c e to the negative 1, then that looks like E must be equal to C, so that I would have E to the 1 times E to the negative 1, which would give me E to the 0, which is equal to 1. So if C is equal to E, then my final equation after plugging in that E times E to the negative 1, or sorry, to the negative T, or if you want, you could combine those together. But that would be our particular solution to the differential equation.